Now I'm going to start my today's session. And as I discussed, I discussed multivariate distribution for discrete case. We discussed a problem over there, how to prepare a bivariate table and how to calculate the probabilities and what are the properties of the probability distribution. In this particular session, I'm going to discuss the same situation, but from the viewpoint of continuity. First of all, for this, we need to know the definition of the bivariate probability distribution in case of continuous variables. So let us try to see what the definition says, because there is a certain part in the definition which we need to understand to solve the problems. And the definition has been, I have written this definition, I have copied this definition from the John Freund's book. Okay. A bivariate function with values fxy defined over the xy plane is called a joint probability density function of the continuous random variables capital X and capital Y, if and only if probability of the pair xy belonging to the region capital A is given by double integration over the region of the function fxy with respect to x and with respect to y, where capital A is an arbitrary region in the xy plane. Now, this is the definition of the bivariate case, and probability in case of bivariate system where the variables are continuous. Now here, the one thing is, one new notation has been implemented, that is called the double integration. Now this double integration, I do not know whether you have any idea about double integration or not, because in first semester course in BSM 202, which is actually not meant for CSE and IT and AIML, there the topic of double integration and triple integration are there. But in CSE and IT and in AIML, in their first semester mathematics course, double integration was not there. So double integration comes when we deal with the function of two variables. Now, actually, when we consider the function of two variables, what does it actually mean? It means that we have to consider a 3D system where these coordinates x and y, they become the inputs or independent variables, the pair of independent variables. So if this is my x-axis and this is my y-axis, then I have to move x units on this line and then parallel to y units on this line, and then I come to this particular point, and there you can put a value, you can assign a value like this, which is the z value. You can say we can treat fxy to be your z, isn't it? So this is the z, and in this manner you can put several values over here. Okay, and if I got this type of values like by putting a different set of pairs in this coordinate plane, then the base of this particular structure which has been erected, that structure, the base is called your this base is actually been denoted by capital A. That is, this is the region, this is the bounded region where in which the variables x and y are taking the values, and with respect to that I'm getting several values for the function fxy. So that area, that is denoted by capital A, and this has been written over here. So it is saying that what is the probability that capital XY will belong to that area. That means what? That means if capital XY belong to that area, capital A, that with respect to this, we will get the probability function fxy, which is defined like this. And then we can calculate the area of this particular structure, which is denoted area multiplied by, you know that area multiplied by height gives you the volume. So we can actually we actually calculate the volume of this structure, and that is represented by double integration. That is the generalization of the single integration to the double integration. and it is written in this particular manner, where we consider the function fxy as the integrand, and we integrate the function with respect to x and then with respect to y. Now, double integration's property says that you can interchange the order of the integration as well. So if you write that it is a double integration over a fxy, you first write dy and then write dx. And then if the situation is like that, you can change the order. Sometimes it becomes difficult to change the order, depends upon the situation. Then you can write it in any manner. Either you can write it in this way, or you can write it in double integration over a fxy dy dx. Now, that is the definition of probability in case of bivariate case. Now, here comes a theorem for you. The theorem says that, as we discussed the bivariate probability in case bivariate probability function in case of discrete case, we wrote that it satisfies two properties. One is the probabilities are non-negative and total probability is 1. In continuous case also, this joint probability density function fxy will satisfy the same criteria, that will be non-negative, and total probability will be equal to 1. Where we are considering the double integration, the first variable range is ranging from -infinity to +infinity. The second variable is also ranging from -infinity to +infinity. Same thing is happening over here, only the summation has been replaced by integration. Now, here is a problem for you. The problem says that you are supposed to find the probability of this, where the capital A is defined by this region. This is your capital A, and the probability function, as you can see, is defined over here. The probability function is 3/5x into y plus x, where x lies between 0 and 1, and y lies between 1 and 2. And we are considering only that area. We are considering an area which is a subset of that. You see, for calculation of this probability, we are considering x to be belonging to the interval 0/2, which is the subset of the interval 0, 1, and y we are taking in the interval of 1, 2, which is a subset of the interval 0, 2. So we are supposed to calculate this probability with the help of the definition this. Now, the solution is written below, but I'm asking the students to try this particular problem by yourself. Okay, put the double integration, put the limits, and try to find out what is coming what you are actually finding out by calculating this particular thing. Now, before I show you the result, you must try this particular problem by yourself. Only thing I can say that if you are putting double integration, if you are putting the probability in this manner, 3/5 into x, y plus x, dx dy, okay, and suppose, and you are putting the limits of x and limit of y in this manner. So in this case, when you integrate that portion, you are going to integrate this portion first of all. Remember, the variable x will be treated as constant, and the variable y will be treated as constant, and you will integrate the thing with respect to dx only. Then you will put the limit over there, the limit of x, and the entire expression will come in terms of y. After that, you can integrate the system in terms of with respect to y, and then you can put the limit of y over there. I'm again saying, if you are writing it in this manner, and if this is your integrand, you can integrate this with respect to x, then you put the limits of x over here. Entire thing will come with respect to y, because in this particular integration, y will be your constant. After that, you will get an expression which will be integrated with respect to y, and then you are going to put the limit of y. And in this manner, you can calculate the probability. So I'm giving you 5 minutes to try this problem by yourself. And once, if any one of you has finished doing this, I'll ask you to write the probability in fraction form, because I do not have the, I so far as I know, the answer is written below in fractional form, and I have forgotten what was written over there. So if I could have calculated the decimal, but in that case you will be biased because you will be able to see what was the solution. I don't want to do that. So please write your answer in the fractional form as something by something. And then I'm going to scroll down to see whether my answer is matching with your answer or not. So try to do it quickly. I'm giving you 3 to 4 minutes. This is the integration which has been performed over here. So I'm asking you to check your calculation with the expression which is written. But the answer is not matching. If you can find that there is any mistake in my calculation, then you can write in the chat box. Otherwise, you can rectify your calculation. And then also you have to write in chat box that, yeah, in which part that was a mistake, in my part or in your part. So this is the calculation which I have done. Now Shubhadeep Sa is saying that it is 11 by 80. Now I'll ask Nikita and whoever it is, Arundhuti, Nikita and Arundhuti. I'll ask both of you to recheck your calculation and rectify the doubts. I'm now, as I'm showing you the answer right now, so I'm explaining what I have done over here. Now, by definition, probability that xy belonging to A is given by double integration over A of the probability function with respect to x and y. Now, since the area is covering the region where x lies between 0.5 and y is lying between 1 and 2, so I'm putting in the first integration, I'm putting x, the variable x, from 0 to half, and then the second variable, it is from 1 to 2. Inside this portion is the integrand. Now, as I told you, I'm going to integrate this portion with respect to x first of all. Okay, then you are integrating the thing. Now, in this integration, while integrating that thing, you have to be careful that the variable appearing y as y needs to be considered as constant. So this variable is constant. We are getting x squared by 2 plus x cubed by 3. What is the limit of x? It's from 0 to half, but don't put, I mean, it would be not correct if you put something for y, because y has not been touched upon. It remains as constant. So the limits of 0 and half has been put over here after certain calculation, and that is, you have to check that whether my calculation is correct or not, because when I actually prepare the note, I do the calculation on the paper, and only the significant portions of the calculation are typed in, not the entire calculation. So I think this will come out. And now you have got an integrand in terms of y only. It's a function of y, and then you can integrate that. Yeah, now they are writing that they somehow did some mistake in the calculation. So they you have got a function with respect to, in terms of y, and that function is definitely can be integrated with respect to y. So we have integrated this, and ultimately the result will come out as 11 by 80. I know that you have not done double integration before, so probably you are not comfortable with double integration. In this case, I will recommend a book. I'm naming it. This book's name is Calculus by Tom A. Apostol. Okay, volume 1. Only the double integration chapter you can study as a reference. Double integration chapter. not the entire book. Okay, I'm just giving you a reference of the book, which you can, where you can get the matter of double integration. We shall be discussing easy problems in our class because actually we are not interested in double integration, we're interested in probability. So anyways, this is the reference that you can take. Now let's see what is there stored for us below. Now, as before, as we always define the probability function, you know that we immediately after defining the probability function, we become interested about the distribution function, which is sometimes is called a cumulative distribution function. And you have seen this definition in case of discrete random variable in my previous class. Only difference is that in the univariable section, that second variable was not present, and yesterday's class there was double summation. But remember that as the definition goes, this distribution function, which is basically the probability that x is lying taking values lesser than small x and y is taking value lesser than small y, when we write the integration, we bring two new variables over here. We don't write it as in terms of x and y. We bring s and t, and that can be done in integration, you know very well. So I'm writing the probability function in terms of the variable st, as if I'm renaming the variables. And that function will be integrated with respect to ds first and then with respect to dt. But the range of the integration is not fixed. It is a variable. It is from -infinity to x. For the this -infinity to x is the range of the variable s, and -infinity to y is the range of the variable t, where x and y in turn is varying on the entire real line. So be very careful that this particular limit is for the variable s which we have introduced, and that particular limit is for the variable which we have introduced here, that is t. And if you can recall the the distribution function is the cumulative frequency kind of thing, where we integrate, we keep on integrating by adding one term at a time. Okay, and at the end, we are supposed to get the final value of the distribution function to be 1, which will be equal to the total probability. So same situation, same meaning, but the notation and interpretation has changed. Now you have this: if the joint probability density of capital X and capital Y is given by this fxy, where the function is x plus y and x lying between 0 and 1, and y is lying between 0 and 1, elsewhere it is 0, we are supposed to find the joint distribution function of these two random variables, capital X and capital Y. So try to do this particular problem, take 5 to 10 minutes time, try to do the calculation, and this particular session is about to end very soon. So in the next session, we are going to continue with the calculation. So I'm giving you some time, try to apply the definition written over here to the given problem, and let's try to see what comes. Okay, do it first of all. And then in the next session, I'm going to discuss from my end about this particular problem. You can take the reference of the for the calculation from our discrete case calculation, which I showed you in the previous class. How to calculate the distribution function. That reference can be taken into consideration to do this particular problem, because we are here not concerned about the joint probability function, but rather the joint distribution function. So you have to be very careful about that.